Cool. So yeah, I wanted to show you what we did for vehicle identification. I will just quickly share my screen. Can you see it?
Mm-hmm.
Okay, cool. So yeah, we need to build a few endpoints so that the mobile guys on Android and iOS can do vehicle identification. So it means like get models in all the version of the models and stuff. So we already have like a mobile API on the main repository. And we already have like methods to get, make, and get models. So we first we checked how it works and what exactly, yeah, like our dependencies and if we can reuse that. And first thing we noticed is that, okay, we can, yeah, to reuse it, it's like not really optimal because it has a lot of dependencies and it's really hard to change. So for example, if you want to get make on the existing flow on the main repository, it's used like something called search values helper, which is by the naming, I guess, related to search. And then it uses something called vehicle adapter. And then it uses like vehicle service to get the make on AutoScout DB. And it uses also IDD vehicle service to get the make and model from Eurotax DB. So it does like something when a join and many operation actually, and it's fairly, yeah, I would not say complicated, but complex mix of service just to get makes actually. So we decided, okay, maybe let's extract this and let's build a new microservice, which can be simpler because we only want to get makes. So it should not be complicated. So our ideas was like, okay, let's extract this and do something new. So we decided to go with Lambda, AWS Lambda. So what we did is that we said, okay, what we can do is like have a table which will contains only make and model and version. So we did like a DynamoDB database. So DynamoDB is like, yeah, type of database owned by Amazon. It's also a NoSQL type of database. So we said, okay, let's create DynamoDB, make table and model table, and then use Lambda function to get the make and get the models. And then on top of that, we have like API gateway that will just aggregate all the function we have. So get, make, get models, and it can also be get versions, get equipment later, maybe something like this. So on top of that, we have like API gateway. And the idea is that for now, we still keep the mobile API that we have because yeah, the app dev, like for now, they won't change. We need to discuss with them like how to maybe change a mobile API and build a new one, or maybe they can go through API gateway later. So for now, they just, yeah, we just still use a mobile API, but for mobile API, instead of going through the existing flow that I just showed earlier, it will just call the API gateway and get, make, and get model without knowing exactly what it does, so without dependencies. And the whole idea is also that once we build this function, Web API can also use that to get the make and get the models. And also, yeah, any other, let's say, consumer can use that. So maybe to give you a bit more context, now the question was like, how do we get the data into DynamoDB? Because as I showed you, we have data into Eurotax, into also AutoScout DB and stuff. So we need somehow to format the data to have this in our table. And also to give you more details, we only want to read the data. We don't want to write it. So the question was like, how do we get data here? So we decided to go with like a function to import the data from AutoScout. So what does it do is that we have like something called a batch, AWS batch here. So basically, yeah, it's like a batch allows you to execute. It can be a Docker image in a repository or anything to execute it based on a CloudWatch. So it's a job, so you can execute it based on a scheduler or manually, how you want. So we decided to go with something called AWS batch, where we'll host something to get like data from AutoScout DB. So basically we get like raw text making models. And then we have something called AWS CloudWatch. This CloudWatch is basically a scheduler which will basically trigger the AWS batch every day, every night. So every night we go to AutoScout DB and we get like error text models. We create file with the change, like a JSON file. So, and then we drop the file into a S3 bucket, which is like just, something where we store the data, basically, just a storage, S3 storage. So we just store a file there. So, and once the file is stored here, we create a Lambda function, which will be triggered every time there is a new file into the S3 bucket. And this Lambda function will populate the DynamoDB table. So what it means is that let's assume we have new models, new things that are created by products into AutoScout DB. Our batch will every night get the data and create a file with a new change and drop it there. And every time there is a new file, Lambda function will import it into our DB. So we did it like this. Right now, we assume that every night should be okay. But in the future, we can assume that here, instead of having S3 bucket, we just use some events. And every time there is a new model, we create an event and we like trigger the Lambda function here. So for now, we assume that this should be fine because we don't have often new models. I talked with products and that, they do like import every Monday and from sometime during the week based on the demand, but it's not like really often. So for now, it's okay, but the trigger is to the S3, but we can always change that later and have like events triggering the Lambda function. So that's like for the general way of working. I can show you a bit. So the import. So let me show you. So if I go to console. So here first, let me show you our DynamoDB table. So this is our DynamoDB table, and this is all the item we have. So sorry, I have a really small screen. Yeah, but anyway, you can see that it's how it looks. So let's just do an import quickly to show you how it works. I will just delete all the items right now. Okay, So here I don't have any item anymore. I will also check something. So let's go to S3. So this is our bucket. So you can see that for now it doesn't contain any object. So let's just manually push some like file into this bucket and see like over database get populated. So I will just show you what the batch contain. So the batch contain, it's here. So the batch is really simple. What it does, it's like we get secret from something called secret manager, where we have like username, password to AutoScout DB. And then we just do like some select to get the data we need from the AutoScout DB. Like we want to get make ID, model ID, make name, So we just do that. And then we will just create like some model, like it's really simple model. F12, it's here, like model. And we push this to S3 to our bucket. So let's just do a quick example. So here we just connect. Here you have like 100 megs what I've been what I get from AutoScout, makes and models. So I can just push them to S3, and so here they are pushed, and yeah, it's over. So that's my batch here, and let's see what I have now. So this is my S3 bucket. You can see it was empty. So now I have my S3 bucket, which is populated. And from this S3 bucket, so maybe I can open it for you just to see what is inside. You can see it's a JSON containing my data. All right. So now from this S3 bucket, I want to get the data and populate my DB. So for this, like I have like a function which will import the data. So this function, it's like it's a Node.js function. I have for like some sources on some GitHub repository, and then I adapt it a bit so I can show you what it does. So it's like a Node.js function. Basically, it just take a SDK. It's a Lambda function. So basically, it also has an handler. So it's we receive an event. This event, it's like contain the bucket name and also object key and also some body. So this event is like triggered by the S3 bucket. So that's why we have like a bucket and name inside this data or object. And what it does is that basically we just have some batch here, and we just use something called a put request to write into the DynamoDB database and into our table. This DB table here, name is vehicle make and models. So I push this. This was pushed already on AWS, so this will get executed. And once this is executed, basically what it does is that it here it populates our table. So you can see it was empty, and now the table contains the data. What was in the S3 file. So this is to sync the data. And now if we really want to go to the point how we really want to get make and models. So we publish like a function, and the function it's deployed. So it's through the API gateway. It's called vehicle identification lambda. So here you can see that you have things to get, make, and models. You can test it directly from your interface. You need like a year and vehicle type. So let's test this. So let's say I want to get something from the year 2000. Say keyboard. Okay, vehicle type. It's 10 for cars. Let's apply this, see if it works. Hopefully. Yeah, you can see that now I get some makes and some more make name. Okay, and basically, so as I showed here, the goal is that to have this function here, get makes, which is called by mobile and web API later. So yeah, that's for the general architecture. I think I worked with Andy on this. Andy did like most of the DynamoDB setup. Maybe Andy, you want to add something or show something?
Yeah, thank you, James. Let me share screen.
Okay.
So can you guys see my screen now? Okay. First, I have written some documents on the GitHub repository here. So first, we have to define the database structure. So you can see what we need in the data, just MAC ID, MAC name, and something properties like that. So the second is we need to know the accept patterns. Like I want to get the max by the vehicle type plus year, and I want to get the models by vehicle type plus MAC ID plus year. So we decide the database like we create the primary key with the prefix max, and the number one here is the MAC ID, and the primary key here is a combined key. So we have the secondary key is a model version. So in DynamoDB, we have a primary keys and it's a unique queue. So you need to make sure when you create a primary key is unique queue. And I also create the index. So because we need to worry with the vehicle type. So I also create a vehicle type plus begin inbox. So for the year option here. And the tools for design database, you can download NoSQL Workbench. And it's tools from Amazon, so it's provided us and it's free. So I show you a little bit about NoSQL Workbench. It's a design tools and modeling. So you can, I mean, you can create a example. You can create a new table on here by enter something like test. Yeah. Sorry, so you, I mean, I create a table named Mac, and here's define a partition key. I mean the primary key, so you can write a PK type string and add the short key SK. So you can create MAC ID. Something like that. And for the global secondary index, I mean, you can create depends on your usage. So I add the table. Then the table is great. You can visualize the data model. So currently the the data is empty, so we can add some data. Then you add some data, you can aggregate view it. It means that have you analyze the data that you want to decide, and then you can commit this table to Amazon DynamoDB directly by using a connection. You can type, yes. I don't do it because it's take a lot of time. So just after you fill on the field, you can commit it. Yes. So that's for the NoSQL workspace. So the next step is we need to grant DynamoDB access permission to the Lambda function. So we define a same template, and in the same template we define a role and something called policy. You can see here. Then finally, we link the role to the Lambda functions. It's here, code here. So in the code, we implement some code like create a new Amazon DynamoDB client. You can see here we have no connection string because DynamoDB, I mean AWS will know which connection string you want to use. So you don't have to put the connection string in, just create new clean. So after that, we create API gateway to communicate with two functions that I created. Then we clean the Lambda function to API gateway by updating the templates in getMake functions, something like this. And finally, we build and deploy the function to AWS. So, I have to create some GitHub workflow for the pipeline update to AWS. You can access it by this link I will send you later. Yes, I think it's easy. So that's it.
Cool, thanks. That looks very interesting.
I have a question.
Yes, any question?
So if we don't have connection string to DynamoDB, what if we have two DynamoDB?
As you know, when you deploy the function and function belong to the region, and the AWS will link the function to the DynamoDB of this region. You get it?
So we only have one instance for a region of DynamoDB.
Yes,
one
and yes, and you have many tables in the region, but only one instance in DynamoDB in the region.
Okay.
But also you can also put something in DynamoDB clean like specific region or something
Like
credentials. Yes, it depends on your usage. Yes.
Okay. So I have another question for Timoko. In your diagram, we need another S3 to save the make and model file. So why do we need that? Because what if we just push the data from the service in the VPN? What does the name?
Yeah, it could be
push directly to DynamoDB.
Yeah, that's really possible to do that. You could do that, but personally, I wanted like to have something that I can reuse later. Because, for example, like I said, like for now we use like you could push it directly, but I think later we want something where we get like events, like every time we have like a new model or mod that is added, when we just push an event and the Lambda function just get like the event and add it to the database. So that's why we like prepared in advance and we did this Lambda function. And if you do a Lambda function that is like a trigger, or if you do a Lambda function in general, it needs to be lightweight, so it cannot like be too long. So it means like if we do like the import through a Lambda function, it will take a lot of time. And so you cannot use like a Lambda function for it.
So in this case, we use S3 as a queue, right? A message
Exactly.
bus. Yeah.
Exactly. So the goal is like, if we have, for example, let's say I will drop 100 files in the S3. I will have like maybe 100 Lambda function created at the same time, which will execute really fast, because for every file I will have like a Lambda function which is triggers. So it's already scalable.
Yeah.
Is there a reason why you chose Node.js?
It was available. No, because I saw this code and it was working well. And I said like, why I would rewrite something in .NET if it's lower. And if this is working, I just need to understand a bit the logic and modify it. So, and at the end, it's a Docker image, so it doesn't matter.
Yeah, okay.
Yeah, that's also the question I'm gonna ask. Like, so if you like Node.js, how can you log if any error, like if we exception, how can we log to the Datadog or something like this? The error handling or something.
I think it's a really easy answer. You can do std out in Docker, and if you probably have JSON format, so like it works out of the box.
Yeah, that's like yeah, it doesn't. Yeah, as Michal said, if you do std out, it's working. You just need to do Datadog integration, and I started it I think 2 days ago. Like to do Datadog integration into our test account. I still need to do some testing, but normally it's not so complicated. Every log will be by right now. I think if you log something on test, every log should be already available on Datadog. I still need to do some testing. Okay.
Because I thought that we logged the error on the IIS log, right? And we seen the IIS log to the Datadog. So now we use the Node.js. So how that's my like how can we like handle the error by using the Node.js? Just my but maybe we have a better solution for it. No problem. Just my
Yeah, that's a good question. But to be honest, that I didn't address yet, but I will write it down. Thanks. Look.
And the Lambda functions are all written in C# otherwise, or the...
Yes, so everything is in C#. I think get makes and models function are in C#. Yeah. Yeah.
Cool. Looks very good. I'm impressed. And did you have problems with the database connection from AutoScout to...
Yeah,
yeah,
exactly. As you saw, I did the testing from my machine, so it was working well. So as the AWS job batch for now, it's like we have kind of issue with a connection to the DB. So I set up the VPC and stuff, but ITO still need to configure like firewalls, policy and stuff. So for now, it's not really working. I think they will come back to me today, and hopefully it gets solved today.
Okay. Yeah. Yeah. One thing we need to tackle is the synchronization. How are we going to synchronize the data to somewhere else also for other microservices?
Yes.
Have their own database. Yeah.
Totally. If I have something, yeah, but I really think we should do is like when we have like we have to read a lot of data. I think it's okay to just create your own database and have like a read-only database.
Yeah.
Based on event and stuff. And like this, you can create data with a model you want, and it's really fast. Maybe you don't even need caching or stuff like this, and then you are really independent. Yeah.
Okay. Yeah. Cool. Any other questions?
I can just say a really good progress.
Mm-hmm. I'd hope to, if we can get some more information in a later stage, how you get on, that would be cool as well. You know, to share how far you are.
Sure.
Maybe in the next one.
Yeah, sure. I think we'll try to deploy something probably next week. We still have to figure out like because right now we have like a weird DNS name, which is like created by AWS. We need to maybe it's something we can decide here how we want the DNS naming to be like. Do we have a convention? Like what should it look like? Like because
that's a good point.
Because we're gonna have a lot of different servers in API. So what naming do we want?
So you're the first. Maybe think about it and come up with an idea, and then we can discuss. Yeah.
Okay, no problem. Cool. We'll do it. Yeah.
Cool. Thank you very much to all of you who participated. If there's nothing else, then I wish you a good day.
Thanks, Pascal.
Have a good day.
Bye. Thanks, guys.
Thank you.
Thanks, guys.
Bye.
It's nice.